Hello, this is Ray Saifzadeh, Senior Director of Product Marketing at Expand Networks. More and more companies are relying on satellite communications these days. While the benefits are great, there are also some challenges, especially when it comes to supporting IP traffic over those satellite links. So what should businesses look for when it comes to choosing a WAN optimization vendor that can support IP traffic over satellite? Here to discuss that with us today is Eric Olson, who is a systems engineer at Expand Networks. Welcome, Eric.
Thanks, Ray.
So, Eric, I know there are so many different satellite environments. Can you list them for us and tell us if they all have the same issue?
Sure. So the first environment that we see is the VSAT environment, which is your most common everyday user environment. This is a pay by bandwidth environment. The next type of an environment we see is your Inmarsat environment. This is an environment that was initially intended for maritime communications. This is a system that is actually quite expensive to utilize. It's a pay-by-the-minute type of a system. And lastly, we have the BGAN environment, which is an expansion to the Inmarsat network that allows for additional bandwidth and also changes the billing structure, which is a pay-by-the-bit system.
What are the main problems they all pose?
Ray, all of these environments have a lot of latency. Okay, they're asymmetrical in nature, so we have different bandwidths on the download as well as the upload. We also experience lots of packet loss. And then the natural limitations of TCP and its three-way handshake.
And are there some applications that are specifically problematic over satellite?
Yes, there is. Where we see applications that are very interactive in nature, such as Citrix, RDP, voice over IP, as well as VDI, all of these applications are latency-sensitive applications.
So, Eric, many vendors claim that they can do optimization over satellite links. What makes Expand different?
Expand is different in the fact that it supports standards-based protocols for TCP acceleration. We support the SCPS protocol. This is a standard of protocol that's been integrated into our appliances and allows us to optimize TCP in a manner that was specifically designed for satellite communications. The additional functions that Expand offers, such as quality of service, compression, object-level caching, these are large differentiating features that not other competitors support. They support one or two different capabilities, but not the breadth of the offering that Expand has.
You spoke about SCPS protocol. Are there any other protocols that are used over satellite links?
Yes. XTP is another protocol that we run into with some of our competition, which is the Express Transport Protocol. This is a TCP replacement protocol and was specifically designed for ATM-type networks in the early to mid-90s.
So is SCPS better than XTP?
Yes. SCPS is designed for satellite communications. XTP truly is not designed for satellite communications.
What if the satellite modem already has acceleration feature? How does Expand handle that? And how does the competition handle that?
Expand offers the ability to turn off our TCP acceleration and utilize just our QoS and our compression alone. Our competition uses their TCP acceleration for traffic redirection, and when they disable the TCP acceleration on their device, it renders the rest of their optimization techniques inoperable.
Being able to adjust bandwidth dynamically is very important when it comes to satellite communications. How does Expand do that?
Expand has integrated some new functions and features into its current release, namely the ability to use TCP Vegas. The way Vegas works is it's able to measure on a per packet basis and adjust dynamically and accordingly to what's required at that time.
Eric, tell us about QoS and how does that set Expand apart?
All traffic passes through our QoS engine. So the ability to give priority and bandwidth to real-time applications, to control the jitter, to control how much bandwidth they can receive, allows for the enhancement of application performance, especially with interactive applications.
Eric, I know Expand has both hard drive and non-hard drive based appliances. What is the benefit of using a non-hard drive based appliance?
Adding spinning media to an appliance lowers the mean time between failure of the device. Because Expand offers the ability to perform its compression in RAM, we can provide devices without any hard disk, which is something that significantly sets us apart from our other competitors that perform all of their optimization on a hard drive.
Expand uses byte-level optimization. What is the significance of that?
When we're talking about interactive applications, RDP, Citrix, VDI, these are applications that use very small packets. When you're talking about the competition that are performing their optimization at the block level, generally the blocks that they use to optimize traffic are larger than the packet size of these applications. Henceforth, they're bypassed within their system. Because Expand's optimization is at the byte level, we have the ability to deal with much smaller packets, therefore can provide an optimization benefit on these applications.
Eric, how widely are Expand accelerators deployed today in satellite environments?
Ray, we've probably deployed over 6,000 devices to commercial and U.S. federal government entities specifically for satellite communications. So Expand looks at itself as the market leader in satellite communication WAN optimization.
So Eric, can you summarize by telling us about the benefits of using Expand Networks appliances in a satellite environment?
Sure. Expand offers a very flexible implementation, being able to utilize our TCP acceleration or not, depending upon the modem that you're using, standards-based technology support with the SCPS protocol, and a robust offering to include QoS, compression, and TCP acceleration in a single device with or without a hard drive.
Thank you very much, Eric.
Thank you, Ray.